running.
Okay, I thought I'd just give you a quick introductory lesson in flint knapping and go through some of the key terminology that we use in studying stone artifacts. So what I've got here is a block of flint, nice quality flint, and we call this the nodule, and it's already been flaked a bit, so you can see some scars here from old flake scars. And what I'll do is I'll just demonstrate the removal of a few flakes, and we'll look at some of the key features that come off those flakes. So what we've got here is a hammerstone, a piece of sandstone, and I'm going to hit this nodule or the core about here, quite close to the edge. So one of the important principles here is that this is the edge angle or the external platform angle between the platform on top and the face of the core, and we want this edge angle to be less than 90 degrees. So you can see the angle there is probably sitting at about 75 degrees. So we don't want it to be too thin, but we want it to be about sort of 75, 80 degrees. And I'm going to hit quite close to the edge with my hammerstone and form a crack, and a flake will come off here. And then we'll have a look at some of the features that come off. So a good way to do flaking, if you've never done it before, is to rest it on your lap, sort of hold the core with your left hand if you're right-handed, and the hammerstone in what we call the 3 chuck grip. So 2 fingers and a thumb holding the hammerstone like so. And we sort of rest the core on the outside of our leg. It's good to have a pad of some kind so you don't drive a sharp flake off into your leg. And the hammerstone action is a kind of a pendulum-like one. It's a rotating action that glances off the edge of the core. And I'm going to try and strike this core quite close to the edge, about 1 centimetre to 2 centimetres in from the edge, above this ridge here. So we'll see how we go now. I'll just try and knock a flake off. And so here we can see I've managed to strike off a flake. A few little bits have come off too. This is typical of flaking, is that sometimes a number of pieces of shatter and flakes will come off at the same time. But the key features here are, you can see that this crack which formed quite close to the edge. And here's the flake that's come off, and I'll show you what those features look like now. So here's the flake coming off the core, and we can see here this is the scar left on the core. This is what we call the negative scar on the core. And here on the flake we have a range of features. Probably the most important one here is you can see the bulb of percussion. If I turn this side on, you can see a bit of a protuberance here. This is the bulb of percussion. And on top here we have the cortex, which was the original outside rind of the flake, the weathered cortex. That's on the platform. And the exact point at which I struck is what we call the ring crack. It's a little protuberance here on the edge of the platform, just above the ventral or positive scar. So that's our platform and the ring crack. Now, on the flake itself, we've got a number of small features. We can see some tiny little lines here around the outside. These are called fissures, and they point back to the point of percussion, the ring crack. We also have, you can see little ripples or force ripples emanating out from this point where we struck the flake, or compression waves they're also called. And these are just like if you dropped a pebble into a pond, you would see emanating out from that impact little ripples in the surface of the pond, and it's exactly the same with our compression waves. We've also got our sharp edges all the way around the outside of the flake, and these are called the lateral margins. We've got here what's called a Hertzian initiation, where we have a bulb of percussion and a ring crack and a bit of a cone of force, but we'll do some more flakes and we'll see some more examples of that shortly. And then we've got our termination, which is at the bottom end of the flake, and this is what we call a feather termination. So you can see side on, it's got a really nice sharp feathered out termination, the way the force leaves the core. And we'll make some other kinds of terminations in a second as well. Now, this was called the ventral surface. This is the inside part of the flake. This is where it came off the core, so this is the surface that's created when we make a flake. On the outside of that flake we have the dorsal surface, so this is the part of the flake that represented the outside of the core before we took the flake off the core. And on the dorsal surface we have a number of key features as well. We have the negative flake scars. These are scars left by previous flake removals, and you can see in this case that last scar is completely outlined, but previous scars on either side have been truncated by removing this flake. Let's have a look at that again on the core. So we can see this was one big flake scar, and this was one big flake scar, But when we took this flake off, we took off a piece of that flake scar and a piece of that flake scar, which now is retained on this flake. So we have a truncated edge and a truncated edge, whereas here we have all of the latest fresh scar. Okay, I'll do a little bit more flaking now, and we'll see if we get some other features. I'm just going to use a harder hammer this time. I'm going to use a little bit of basalt this time to do some flaking. We might see a slightly more pronounced bulb of force. The other thing I'm going to do quickly before I start is when this flake came off, you can see because of our bulb of percussion, or that protuberance, leaves quite a big dent or negative imprint on the core. And as a result of that, if we look side on, you can see that edge is quite sharp and quite low angled now. And that's not ideal for flaking. If I was to strike here right on the edge now, it would crush. So what we typically do is we brush off that, or abrade that edge, that sharp edge from flaking, using our Hammerstone, and it just looks like this. It's just a series of small flakes detached from the edge, and this is called overhang removal. So we're removing that overhang, or that sharp lip that used to protrude off the edge there. And you can see what result that has on the core, a series of little flake scars left on the platform edge. See those there? Okay, so I'll take a few more flakes off now, using my hard hammer, a piece of basalt. Okay, now before I go any further and take that off, I want you to notice this thing here. This is the ring crack. Can you see that little semicircular protuberance? We've got a really nice ring crack this time. And now this is the platform of our flake again, so we'll take that away. You can see how that refit onto there. It's left a nice big scar. And if we look at our flake now, there's some nice features here that we can look at. One is, here's our ring crack. Here's our ventral surface, the surface we just created. And we can see a little bit of a cone just coming out from that ring crack. Because it starts with a semicircular top, we get a little bit of a cone emanating out from that. It's not super clear on this flake, but up close you can see just a bit of a protuberance coming right out from that ring crack, and that forms the bulb of percussion just below that. Here again we can see the fissures down the side, these little thin lines pointing back to the ring crack. And the force ripples aren't as clear on this one, but they were a little bit clearer on the last one. And on the outside surface we have our negative scars again. Here we can see overhang removal. These are little scars on the platform edge. Our platform has mostly cortex on it, one small flake scar as well. And our termination is again a feather termination, so it comes to a very fine, thin edge. I'll see if I can make a few more flakes that don't have just a feather termination, but maybe a hinge or a step. Okay, here we've got a step, or is it a hinge? A bit of a hinge termination this time. So if we join our flake on, instead of the flake just coming to a nice feathered end like in this case, it's left an abrupt termination. You can see that little bit of a concavity that's left on the edge there. That's right. And that's called a hinge termination. So it's rolled out and the bottom of our flake is actually broken off. But we can see, if we join that back on, that our flake has rolled over at the end. The termination has rolled over into a hinge. Okay, just make a few more scars, a few more flakes. We'll see what other features we get. So we got another hinge termination here this time. You can see that that flake rolls out again, the way the force leaves the core. And this time we actually get a slightly better cone of force on our flake as well. You can see a nice cone emanating out from our ring crack. Bulb of percussion. The ripples are quite clear on this one as well. A couple more quick flakes. See what other features we get. This time we have a beautiful cone of force. You can see these little lines coming right out from the ring crack. And some lovely fishes again around the outside, again pointing back to the ring crack. A little bit of overhang removal on the outside and some negative scars. Okay, so I'll just take you through one or two more features now. I talked about overhang removal, and I'll do a little bit more of that now along the core edge. So just brushing off that fine, sharp overhang left by the last few removals. But another way that we can prepare the platform, which is this upper surface here, is we can take flakes off. So in overhang removal, we're striking the platform down onto the dorsal to remove these fine flakes and remove that lip. But another kind of platform preparation is where we strike flakes from the dorsal back onto the platform. And that's to shape the platform, maybe to create a concavity, or maybe to create a convexity, maybe to change the platform angle. And so for that, we turn the core over, and now we take a small number of flakes back the other way. In this case, we're removing a bit of cortex in the process. And this is called faceting. Faceting the platform. So you can see now that our platform has changed from being cortical to having a series of small flake scars along it. And what happens now if I take another flake is we'll see that that platform of the new flake will have faceting on it. So here's our flake. Here we got a lovely feature that I also wanted to show you this time. You can see this little tiny scar here on the bulb of percussion just below our cone of force. This is called the Aurelia scar. This is quite typical of percussion flaking, where we have a Hertzian cone and a conchoidal fracture, as we do here. So with a bulb of percussion, nice cone coming out of the ring crack at the top here. On the bulb, it can be right in the middle, it can be off to the sides, we get this Aurelia scar. And one of the interesting things about the Aurelia scar, if I can get the lighting right, is that you can see little tiny ripples all the way through it. And those ripples are often at a slightly different orientation to the main ripples on the flake. So on our ventral surface, our ripples go like this, but on the Aurelia scar, they actually go in this direction. So they can be very distinctive. Okay, and just to point out that one feature I was going to show you, instead of cortical platform like we had previously, we now have lots of little flake scars. And they initiate from the dorsal surface onto the platform. So we can see little tiny crushing marks and little cones of force where those flake scars came from the dorsal onto the platform. And this is faceting, platform faceting. And on our dorsal, we've got our negative scars. We've got ridges dorsal ridges between the scars, and here we've got a little bit of cortex. So we've basically clipped the bottom of the core where we can see a little bit of cortex still remaining on the base of the core, and a nice feather termination on this one as well. Okay, a couple of last things. What I've been using so far are hard hammers, or hammerstones, and you can see as a result of that little bit of hitting I've been doing, there's what we call pitting appearing on the base of the hammerstone. This is typical of percussion flaking, freehand percussion flaking. You get the same thing with bipolar flaking where you're using a hammer. And on our sandstone hammer, our softer hammerstone that I've been using, you can see that pitting is quite pronounced, which is indicative of a lot of percussion flaking. Now, we don't always use stone when we're making stone artifacts. Sometimes we can use bone and wood. Here's an example, for instance, of a piece of antler from a moose from the United States. Big, heavy-duty antler. And this is generally called a billet, and it's what's called soft hammer flaking. So antler is much softer than stone, although our sandstone is quite soft. But compared to our piece of basalt, this is a much softer hammer. And it's used a lot when you're doing very fine thinning work. For instance, if I wanted to take a very long, thin flake off here, my antler would likely produce some very long, thin flakes. So we can see, for an example here, very long, thin flake. Here's a better example. Get these long, thin flakes. And they'll still produce a bit of a bowl of percussion, but often that bowl of percussion is just very slightly less pronounced than we see when we use a hard hammer. And here's our faceting on the platform again. See those little scars coming in from the dorsal, which is cortical now, onto the platform. Our bulb of percussion. Nice feather termination there. A lot of cortex on the dorsal surface. One last technique I'll show you is, this is all called freehand percussion so far, where we're striking the core with a hammer, either a soft hammer or a hard hammer. But another technique we can use is called indirect percussion, where we use a punch instead of using direct freehand percussion. So now we're actually going to use, let's put it like so, a punch to strike off a flake. Now here I've got another piece of antler. I can basically position this punch exactly where I want the flake to come off. I can put it right on the edge like so, and then striking it, a little flake will come off. And now this is exactly what I wanted to show you. When we're using a punch, and often when we're flaking very low edge angle cores with a very sharp edge, instead of the classic bulb of percussion with a cone of force, an Aurelia scar bolt, and a ring crack, we actually get something quite different. You can probably see it here with the shadow, the way it's just falling on it. We get a lip. So instead of that, if I just hold up another one to compare, so here we have our Hertzian cone, Hertzian initiation with a conchoidal fracture. We can see the cone of force coming from a bulb, from a ring crack onto the bulb. Here, we don't have that. We just have this lip, and the shadow cast across there. So in cross section, if I turn it side on, you can see instead of a bulb of percussion, we actually have a concavity caused by that lip. And this is called a bending initiation. And the reason we get a bending initiation is when I had my flake attached to the core here, like so, I placed my hammer, my punch rather, right on the edge. Just get that so you can see clearly. I had my punch placed right on the edge. And when I struck it though, the fracture didn't initiate right on the edge, it actually initiated behind where I had the punch placed, resulting in the fracture bending quickly down below the hammerstone and giving this kind of unusual lip, the bending initiation. Okay, I'll just show you one last form of flaking that we often find in the archaeological record, and that's called bipolar percussion. And with bipolar percussion, instead of holding the core in the hand and using freehand percussion, we now place an object on an anvil, so it sits underneath the flake, and we hit it from above. And so that now we have percussion coming from two directions, from beneath as the flake is compressed onto the anvil, as well as from above. And when we do this kind of flaking, we get lots of little flakes popping off, and we get lots of crushing at both ends. You can see the crushing already appearing there. I'll do a bit more and you'll see it gets a little bit more pronounced as we go along. Okay, here's a classic kind of bipolar flake that just came off. Long, thin, lots of percussion ripples. You can see those there. This is where the flake came from, something like that. You can see the crushed initiation, lots of force ripples, and the flakes tend to be quite unusual. They're very thin and splintery. Just do a few more of those. And this kind of bipolar percussion is very well suited, there's another one, to making long, thin, splintery flakes from very, very small nodules or cores. And people often used bipolar percussion when their original nodule, their original core, got worked down, 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 down until almost nothing was left. They still wanted to make flakes from it, so at that point they'd put it on an anvil and bash it like so, and lots of these little thin splintery flakes would come off, resulting in these crushing at two ends, lots of percussion ripples, sometimes a bulb of percussion at both ends, one at the bottom and one at the top. And you can see on the anvil now lots of little splintery flakes all around, a lot of debris being caused from this technique. Look at this little tiny blade that was produced from Bipolar. I'll just go for a second or two more. Lots of little flakes splintering off there. This core's almost had it. More little flakes splintering off. And now we've really reached the classic bipolar core form. You can see the crushing at the top, the crushing at the bottom, lots of heavy rippled flakes, particularly on this fine flint, longitudinal ridges or flake scars running all the way down. And most important of all, notice at this edge we get a crushed ridge. And that's the result of constantly splintering and crushing using wedging initiations, they're called, where you're crushing off the flake. And at this point, on the opposite end, notice we don't have a ridge, we have a point. And this is very typical of bipolar cores. It will have a point at one end or a ridge at the other. Some will have a ridge on one end and a ridge on the other end. Some will have 2 points. So bipolar cores can have a variety of forms, but they all have this heavy crushing, often with clear indication of initiations from both ends, wedging initiations which result in crushing. Okay, that is a little introduction to flaking and terminology, so I hope you find that useful.